In this video, I'm going to be working some arc-length examples. I'm going to be working through Calculus BC extra practice for 8.1, specifically for perimeter, arc length, that type of stuff. So, all right. Region R is bounded by the graphs of, let's see, still here, y equals 1 and y equals 1 plus x cosine x, which kind of looks like that. I don't think I might have messed up the concavity a little bit there, but it'll be all right. We want the perimeter of R. So what we're going to have to do is we're going to have to figure out, what is the x-coordinate here of the intersection, because that's a horizontal line, and I'll be able to find that part. This will require an integral, the curved part, but we just learned how to do that, so we should be able to do it. Okay, so I want to know where 1, because that's the equation of the horizontal line, is equal to 1 plus x cosine x, which is the equation of the curve. Okay. And if I subtract 1 from both sides, that's where 0 is equal to x cosine x. And if you did the extra practice for area between two curves, and you've already done this, and you know that means either x equals 0, which is, well, that's that one, I already knew that, or cosine x equals 0. And that would be where x is equal to pi over 2. Okay, so now I know that the x-coordinate of the intersection is pi over 2, and I can say that the length of that segment is also going to be pi over 2. So my perimeter will be equal to the length of the line segment is pi over 2. And then I'm going to add in the length of the curve. Okay? The length of the curve is going to be the integral from 0 to pi over 2 of the square root of 1 plus dy dx squared. Okay, so we're going to need to find dy dx. So I might do that up here. Okay, if y equals x cosine x, then dy dx is going to be, I'm going to have to use the product rule. Okay, so take the derivative of x, that's the easy one, and leave cosine x the same. And then I'm going to leave x the same and take the derivative of cosine, which is going to be negative sine. Okay, yeah, and I'm still visible. So what I'm going to do is I'm going to take this, that's dy dx, I need to square it. So I'm going to have cosine x minus x sine x squared inside the square root integrated with respect to x, and that's a job for the calculator. This, you have no chance of being able to empty differentiate that by hand. Okay. So what we're going to do is we're going to say pi over 2, don't forget about the original pi over 2, plus the integral from 0 to pi divided by 2 of the square root of 1 plus, open up the parentheses, whoops, so it'll be cosine x minus x sine x. Okay, that parenthesis was the end of dy. No, I need another parenthesis there. Cosine x. Okay, yeah, and then I'll square here. So make sure that square is underneath the square root with respect to x. And that might take a second. Okay, 3.566. All right. Number 2 is going to be find the perimeter of region U, and I'll just give you a little sketch of region U. All right, so region U, it kind of starts up here at 1. That's x to the 4 plus 1, and it just goes over 1. All right. Okay, this is 1, and that's 2. This is right here, x equals 1. So this has got a width of 1. That's got a height of 1. So I'm looking at perimeter equals 2, 1 plus 1 plus the length of that curve. Now, the length of the curve is going to be the integral from x equals 0 to x equals 1 of the square root of 1 plus dy dx squared. Okay, to me, that's going to be, well, if y equals x to the 4 plus 1, then dy dx is going to be 4y to the third. Or 4x to the third, pardon me. And 1 plus 4x cubed squared dx. All right, and this is going to be 2 plus math 901 square root of 1 plus 4x to the 3 squared dx. This is going to be 3.600. All right, number 3, find the perimeter of A. A kind of starts over here at 1, and then it goes up with, this is y equals square root x minus 1. This is x equals e. Yeah. And, okay, so, and then this is, okay, this is going to have a width of, that's going to be 1. This has a width of e. This has a height of square root of e minus 1, because that's the height of the graph right here, is y equals square root of e minus 1. So this will be square root of e minus 1. And then we'll just need the length of this graph, which I am realizing might be hard to compute because the derivative goes and, you know, doesn't exist. Or, yeah, derivative doesn't exist here at x equals 1. So we'll see. We'll run it through the calculator, see if it gives us a number, see if it seems reasonable. But again, this is another one of those, like, there was one like this on homework 8.1. You got to be careful with radicals, finding the lengths of them at the edge of the domain because of basically the vertical tangent situation. Okay, so either way, I know that this has a length of 1, so my perimeter is going to be equal to 1 plus e plus the square root of e minus 1 plus the integral from 1 to e of 1 plus dy dx squared on that curve. So the square root of 1 plus the square root of x minus 1 is x minus 1 to the 1/2 power. Okay. So y prime is going to be 1/2 times x minus 1 to the negative 1/2. Which is 1 over 2 square root of x plus 1s. I'm going to square that. Still in my shot. Barely. All right. So this is kind of, oops. So 1 plus e plus the square root of e minus 1 plus the integral from 1 up to e of the square root of 1 plus dy dx squared 1 over 2 square root x plus, that's got to be a minus. Yeah, that's supposed to be a minus. Okay, close the parenthesis, give it a square, integrate with respect to x. It's thinking. It's really thinking. What do I think? I'm looking at the image. I know it's drawn to scale because I graphed it myself. So 1, 2, 3, 4, maybe. I don't know. I'm a little suspicious of this. This would be 7.291. Seems close. Okay, either way, that integral's right. I'm just not sure if that integral actually exists. So, I don't know why I would go straight from 3 to 6, but I'm going to take number 4 now. Perimeter of B. So, B is the one that starts at 1 and goes all the way to E. And it's like, okay, here we got log of x, and there we've got square root of x minus 1. Again, this is, finding the perimeter is going to be troublesome because of that curved piece, and it's probably going to take the calculator forever to compute, but it's all right. We've already got this thing here, so we're going to use that integral. That's going to be part of it. There's going to be another integral, and then there's going to be this little vertical piece here. Now, maybe we'll do some work on the vertical piece. Okay. So if this is x, the height of this point here is going to be 1 because, well, x is equal to e, y is equal to the log of x, so y is equal to the log of e. The log of e is a special exponent I would put on e to get e, and that's going to be 1. Okay. And the top, the x coordinate there, that's going to be the square root of e minus 1. So I'm going to say that this vertical distance here is equal to square root of e minus 1 minus 1. And then I will say, all right, my perimeter is on screen. Perimeter is equal to square root of e minus 1 plus the integral from 1 to e of the square root of 1 plus 1 over 2 square root x minus 1 squared, then plus the integral from 1 to e. Okay, we've got to do these separately. Okay, if I wanted to combine them and run them as one integral, I'd still need 2 different square roots. So I say just do them separately. 1 to e of, okay, if y equals log of x, then dy dx is 1 over x. So it'll be the square root of 1 plus dy dx squared. And I'm going to do that on the calculator. Maybe I can do a little better on this. So I would want to insert a -1 here. -1 plus the square root of e minus 1, yeah. Plus the first integral, I'll let it think about that one. And then I'll add in this second integral right there. There we go, 2.573. And so I'm going to take plus math 9, 1 to e of the square root of 1 plus, let's see, dy dx was 1 over x, square it, dx. I get 4.576. Okay, and that's going to be the perimeter of region B.
If you are not with...
All right, number 5 is perimeter of region C. And I'll just give a quick sketch of that one off to the side. So from x equals 1 to x equals e, this is y equals the log of x. Just I'm out right. Okay, this has length e minus 1, right? Right minus left. So it's e minus 1 plus, okay, the height here is going to be, well, that's y equals log x, x is e, so it's the log of e, which is going to be 1. Okay. So plus 1 plus, and then I'm going to need, okay, if y equals log of x, that means to me that dy dx equals 1 over x. Okay. And dy dx squared is going to be 1 over x squared. So I'll integrate from 1 to e, the square root of 1 plus 1 over x squared. Okay, if you want to just throw parentheses around the 1 over x and square that, that's the same thing. Okay, so e minus 1 plus 1, that's going to just be e. Let me grab a calculator and let's get this going real quick. Okay, So e plus that integral, so e plus the integral from 1 up to e of the square root of 1 plus 1 over x squared is x to the negative 2 dx. It's 4.722. All right, and number 6 is going to be find the perimeter of D. All right, okay, this should be a good one. So for D, that one's bounded from below by y equals 2 minus cosine x. And from above by this horizontal line that it's not very nice and didn't tell you about. I think for reasons that we have seen, not in this video, okay, if you worked the extra practice for the area, then you would have seen that, okay, you determine that this vertical line here has x coordinate pi over 2, because that's where y equals cosine x hits 0. Okay, and that's the first time in, the positive x world where cosine x equals 0. Okay, so that means that this segment has width pi over 2, and, well, if it's 2 minus cosine of pi over 2, so it's like y equals 2 minus cosine x. Well, cosine of pi over 2 is 0, and so y2. Okay, so this is y equals 2, and this is going to be y equals 1, because that's also where the graph of y equals cosine x starts. It's also where the graph of 2 minus cosine x starts. You plug in 0, you get 2 minus 1. Okay, so that's going to have a height of 1 here. That's going to have a width of pi over 2. And so I'm going to say that, my perimeter is 1 plus pi over 2 plus the integral from 0 to pi over 2 of the square root of 1 plus some type of thing squared. So dy dx is y prime equals positive sine of x, because the derivative of 2 is 0, and the derivative of cosine of x is negative sine of x. And so, minus negative sine is going to be positive sine x. So okay, 1 plus sine squared x, that's the type of thing trigonometrically. It looks like there's something you should be able to do with that with the trig identity or something. There's not. Besides, just substituting on the sine squared x, right? And then, you're really no better off. So, let's see. So 1 plus pi over 2. Square root of 1 plus dy dx was sine of x. I'm going to square that. Oh. Okay, that's a little frustrating, but it's all right. What can you do? Plus the integral from 0 to pi over 2 of the square root of 1 plus dy dx is sine x dx. That's going to be 4.481. Right. Now, knowing what I know about kind of the symmetry of that whole D, E, and F situation, I think if I want to find the the perimeter of E, I'm gonna actually do that. Whatever. I'll just do it with integrals. That's the whole point of this exercise, is extra practice on arc length integrals. So, I mean, you could just kind of like figure out what that integral was, double it, and add 2, right? Because that part of 2 minus cosine x and cosine x are essentially the same curve. They have the same derivative, so they're going to have the same length, right? Over the same x interval, which is what we're looking at. But I can still do this. I'll say that this is so. Okay, why did that? All right, so for this first one, okay, y prime is equal to sine of x, and for this one, y prime is negative sine of x. Okay, so they don't exactly have the same derivative, but the square of their derivatives is going to be identical, so they'll have the same arc length. So, what am I doing here? I'm thinking perimeter is going to be, this is 2, for reasons we've discussed. Perimeter is 2 plus the integral from 0 to pi over 2 of the square root of 1 plus sine of x squared dx, and I'm going to just double it. I think it's pretty evident that that length is going to be the same as that length, especially if you're looking on the original, sketch of the region on the original document. So I've got, 2 plus 2 integrals from 0 to pi divided by 2 of the square root of 1 plus sine of x squared. No. Okay. And I will get 5.820. Yeah, it doesn't seem. Okay. And that's all I've got for these problems. And I think that's just going to be all for the video. I've got another practice set for arc length and perimeter. It's online, it's through the computer, and it's it's from when I was giving this class remotely last year, and I think I'll work those problems in a separate video, and I'll say like even more arc length examples or something like that. So thanks for watching.